Okay, welcome back my 8th grade YouTubers. So I'm pretty excited about this video myself. This video is about transformations. So transformations we've been studying for the last couple of days now, actually since Tuesday when you guys got back from your spring break. A transformation is when you take an image and you actually change it on the coordinate system. Now, the two transformations that we've changed so far, because you can change the size, you can change the shape, you can actually change the orientation, or you can actually just move the actual object. What we've been studying is moving the object and changing its orientation. So when you move an object, you can move it to the left, to the right, up, or down on a coordinate system. And this is called the translation. When you reflect something, it's like a mirrored image. You're staring at a mirror. If I told you to hold up your right hand in the mirror, if you went ahead and did that, it would actually look like that person in the mirror was holding up their left hand instead. So that's what we've been studying, translations and reflections. So what we're going to do is we're going to actually answer from your homework question number 1, 2, and 3 on the back side. Because a lot of people probably have trouble with the later questions on the homework, which is the second page, not the first. We have 4 different quadrilaterals. Quadrilaterals are things that have 4 sides. This is quadrilateral F, quadrilateral G, quadrilateral H, and quadrilateral J. And we put them on a coordinate system. So the first thing we need to know is we need to know what the 2 axes are called on a coordinate system. This axis, we should know, is called the x-axis. It's the flat line horizontally across. And this axis right here going vertical is called the y-axis. That's going to be really important that we know which one is the y-axis and which line is the x-axis, or else we really can't answer these questions. In question number 1, we're asked to figure out which one of the 2 quadrilaterals is a reflection over the x-axis. So this is the x-axis. This would be your mirror. This x-axis, we have to think of this x-axis when we're reflecting across it as a mirror. This would literally be the mirror. And what we're trying to do is we're trying to reflect things. Well, if you reflect things, the distance between you and the mirror should stay the same. So if I hold up my hand to the mirror and my hand is closer to the mirror, when I'm looking at the mirror, my hand should still look like it's closer to the mirror. So we have to make sure everything in terms of distance stays the same. The only thing that turns into the opposite is the orientation. Orientation is actually going to go ahead and change. So instead of looking forward towards the mirror, it's going to look like the mirror's facing towards you now. And so that's what we have to remember. Which one of these are being reflected over the x-axis? Well, let's take a look at this one, F and H. If we have to reflect, and this is our mirror, let's really see if this looks like it's a reflection to this image here. So let's take a look at this point here and this point here. See, the distance away from this image, we can see it's about this far away. And it should be this corner. Well, we can see if we're taking that same distance, it doesn't match up, does it? This corner is this far away from the x-axis. But if we bring down our 2 fingers, it doesn't match up where this corner would be here. And the other thing that we can see is that this corner right here seems like it's actually over here instead. That doesn't make sense. A mirror wouldn't do that. In a mirror, this corner should still stay where it is, just on the opposite side. It's almost like flipping something. it should match up exactly the same distance. Let's see how this one actually matches up here. If we put these corners here, and we actually go ahead and take a look at them here, we can actually see this longer part here actually matches up this longer part here. See, you can actually see this image here, and I want to go ahead and outline them a little bit darker for you. You can actually see this looks like it's just been flipped, like it's literally just been flipped over. This corner is the longer point of this quadrilateral, and this corner here, it's still the longer point. You can actually see that. This would be the shorter. And you can see the shorter point. Can you guys see that the shorter side right here, these points that make this shorter line, this shorter side, it's actually further away from the mirror. Can you guys see that this is further away and it's still further away down here for this side? This makes more sense that this is a reflection. This is the image. This is called the reflected image. This is our image, and this would be its reflected image. These two images, G and J. G and J are reflections over the x-axis. So if we were answering number 1, we would say quadrilateral G and quadrilateral J. They're reflections over the x-axis. In question number 2, we have to figure out what two images are reflections over the y-axis. Well, this time, this is going to be our mirror now. So this is going to be our mirror right here. So I'm going to go ahead and put that in red. And then we'll go ahead and we'll put that x-axis back. And we want to make sure that that x-axis, you're not going to focus on it. See, this x-axis is not going to be our mirror anymore. Now we want to focus on the y-axis. So this is the one I want to highlight in red. I want you guys to focus on this vertical line. See, we're trying to look at which one of these quadrilaterals look like they're reflected. And you have to remember, the distances should stay the same. So you want to kind of focus on a key point or a key side. For me, I like focusing on this longer pointed corner here. See, this pointed corner is very far away from the mirror. See, this is going to be my mirror right here. This is my mirror. Okay? This right here, I'm reflecting so that whatever's on this side, it needs to be the same on the opposite side. So let's take a look at that corner. If this corner here is the furthest point away from the mirror, it should still be the furthest point away on the opposite side. This is the furthest point away from the mirror on the right. It should stay that way. This doesn't stay. Look it. Can you guys see that this corner is very close to the mirror? And on the opposite side, it's far away from the mirror? It wouldn't look like that in the mirror. Remember what I said about stretching out your hand towards a mirror. If you stretch out your hand towards the mirror, even in the mirror, it's going to look like your hand is very close to the mirror on the opposite side. This point is far away, and on the opposite side of the mirror, it's very close. That wouldn't happen in real life on a mirror. So these two images are not reflections of each other. Let's take a look at this point here. Here, this pointed corner, it's the furthest away from this mirror. Let's see if it's still the furthest away over here. Yeah, and it's exactly the same distance as well. Look at how my finger is this far away from this finger. It stays exactly the same distance on the left side. So these two quadrilaterals are being reflected over the y-axis. So I'm going to put quadrilateral F and quadrilateral G. Now, in question number 3, they want to know, well, what's the relationship? If this is not a reflection over the y-axis, what kind of transformation, how exactly are you changing these things? Well, these are actually translations. What kind of translation? Well, here's where you want to go ahead and count. You want to go ahead and put a pencil on top of this point, and you want to put your pencil on top of this point. Here's where I'd like you to pause the video. And what I want you to do is I want you to count how many times you'd need to go ahead and move from this point to get to the other point. But I want you to choose the same corner. I want you to put your pencil on this corner here, and I want you to count how many times would you have to count on the coordinate system. Count the number of squares until you got to this point. And what I want you to do is I want you to write your new answer in something called translation notation. And we learned what that was earlier this week. So I want you to go ahead and pause the video now, then go ahead and write your answer down, then unpause and check your video. I'll give you a chance to pause the video now. Okay guys, welcome back. I know that you went ahead and you counted how many spaces you'd have to move from image H to image J. So if we were counting 1 square, 2 squares, and we wanted to count how many squares it was, hopefully you guys found out that it would be 10. So what you would do is you would actually go ahead and write x plus 10 here. But here's the thing about the y. This image doesn't change when you reflect it, okay? Well, it also didn't change when you translated it either. Now, reflections just happen to be so that if this is a number on the y-axis, it should be the same number here on the y-axis. But you can see that this is called a translation. And just by chance, we just moved this 10 spaces to the right, and we didn't move it up, and we didn't move it down. So this actually would be just y. You could put y plus 0 here. And a lot of people will say, well, do I really have to put the y plus 0? Can't I just put x plus 10 and then y, because the y number stays the same? Whatever y number this is the same y number here. Yeah, you could actually write your answer like this if you want. So it's going to move 10 spaces to the right, so we put x plus 10. And the y number doesn't go up or didn't move down, so the translation has the same y value. Well, hopefully this is going to help you out a little bit when you guys are going ahead and checking your answers. So at this point in time, you can go ahead and see that all of this right here would be your answers for number 1, 2, and 3 for your homework due on Monday. Well, I'll definitely see you guys in class on Monday, and hopefully this is going to help you for your homework. See you next week for your next YouTube video. Take care, guys.